Hello, we are HydroCrop Solutions, and my name is Quan Yi, and my teammate Frank. Together here, we are presenting our innovation idea to address climate change. So the target problem for the project is to address climate change, especially drought and global warming on the impact of the agriculture. For the past decade, there's about 1.5 Celsius degree increase overall. So the increased temperature will lead to increase of evaporation of the surface water, which causes water losses during the traditional irrigation method, and which is also another aspect that we like to address in the project. So our idea have two main parts. So the first part is the rainwater tank on the surface. The rainwater tank on the surface were able to collecting rainwater during the rainfall event. And also the tank itself, it connects to a subsurface pipeline, which is located at the crop root zone about 0.4 to 0.6 meters underground. So the uses of the subsurface pipeline is to irrigate the crop at the root zone and to limiting the water evaporation at the surface. And we do understand excess water will flow downward to the soil profile and eventually heading to the shallow groundwater aquifer underneath. So our numerical model and also counted this much of water that flows to the groundwater aquifer, and next Frank will demonstrate how the numerical model was developed and the calculations.
Now we will take a look about the code implementation. Please note that in this demonstration, we have hard-coded the values for simplicity, but in real-world scenario, these values can be adjusted to accommodate different situations and variables. On the first, we have a dictionary called plant that contains hard-coded values representing the water usage percentages for different plants. Also, there's a parameter section to represent the actual field data. And we have a series of calculations that utilize the hard-coded parameters to determine the water balance and availability within our system. In this early version, this calculation are implemented using fixed values, but in a production-ready version, this parameter can be inputted by a user or fetched from a data source. And there could also be a machine learning approach to get a more precise water usage.
So there's two advantages for our innovation idea. So first, in the traditional irrigation way, there are about 25 to 40% of water being lost in the surface due to evaporation. So our subsurface pipeline can avoid this bit of water loss. And also the integrated water management system not only saves water, but also help farmers go through the dry period when there's no rainfall. The limitations are obvious too. So how long the system can run for during the dry periods purely depends on the rainwater tank. And also to make sure the implementation is successfully conducted, we are required to have a detailed site investigation to understand the soil property and distance to the shallow groundwater aquifer.